Everyone, and welcome to today's webinar on modeling for flexible components. My name is Nick Exposito, Marketing Director here at TriStar, and I'm very pleased to introduce our presenter, Sean Schreckengost, Business Development Manager at TriStar. Before we get started, I just want to do some quick bookkeeping and mention that a complimentary recording of this webinar will automatically be sent to everyone who registered. It will also be available on our website and our YouTube channel shortly after the presentation. If you have any questions, please feel free to leave them in the chat question box up in the upper right-hand corner, and we'll try to hold a brief Q&A at the end. So without further ado, I'm going to hand it over to Sean.
Okay, thank you, Nick, and thank you everybody for attending today. This is a presentation that deals with modeling for flexibility in our Creo assemblies. And when we think about flexibility, it's not necessarily something made of rubber, right? It's really how do things vary inside of an assembly. So before I get into the presentation, a little bit about myself. I'm a business development manager for TriStar. I've been with TriStar for 14 years. Previously with PTC for 16 years. I have a 44-year background in mechanical engineering with 42 years experience on different CAD platforms. I've probably been using CAD for longer than some people have been alive in the audience. I've been using PTC tools for 37 years and 27 years with Creo Parametric. Of course, that started back in the Pro E days and then went through Wildfire, and here we are with Creo. I live in a very small town in the middle of Colorado. It's a very nice place to live for us anyway, just out in the middle of the state. So when we talk about flexible components in an assembly, a flexible component is a part or subassembly that really is going to change inside of the assembly. It's different in each instance in the assembly. And so these are some examples of different parts that we may purchase off the shelf, and we put them in our assemblies, but when we put them in the assembly, they are in a different configuration. For example, a hose clamp, the diameter would change. For a tension spring, the length would change. A compression spring, kind of the same thing. An O-ring would compress, and then there on the far right here is an example of a battery clip. So once the battery gets put in the clip, it's going to expand a little bit. But there are many other examples of what we would consider a flexible component in the context of an assembly. So really, when we think about creating these types of parts, in the past, a lot of companies have created family tables to represent the different variations in the assembly. So we would require a family table instance for each assembled variation. Of course, we know that when we're using a PLM system, there's a lot of overhead with family tables in that PLM system, and we're finding more and more that companies that really have a lot of family tables, they start having problems with users making changes to instances of a family table without actually changing the generic of a family table, and then they start getting into a lot of trouble there. There's also bill of material accuracy issues when we use different instances from a family table in our bill of materials. Then we have to represent each of those as a line item. When we use a flexible component in the assembly, what we're really doing is we're modeling one component, but when we assemble it, it's how we assemble it to make it variable. And then we'll show you that, of course, in the demonstration. There are some challenges and considerations in the assembly. First of all, how does this component get assembled? And then what drives the variability? And that's going to be different depending on the type of part that you're creating, whether it's an O-ring or a clip or a spring, things like that. There's different things that are going to drive the variability. So when we model for flexibility, we really got to develop an approach for the particular component, but we need to know more about the features that are available in Creo. I'm going to show you some features today that you may not be aware of, as well as some techniques to actually capture the design intent. Those techniques are going to deal with sketch geometry, not just solid geometry, but also using construction geometry and constraints within the sketch. We're also going to use parameters and relations to help drive the flexibility. And when we model these parts, we have to model them for both the static state and the dynamic state, or how it's going to vary. Now, I've always been a stickler for modeling design intent, right? Just get the dimensions that I need for this part to document the part and manufacture the part. This is different though, because a lot of these parts we are purchasing. We're not going to make the part. We're not going to detail the part. We're not going to create a drawing. At best, we're going to have a specification from the manufacturer that we might put in our wind chill system to document that in a WT part. So that would go with the model that we create. So there's a lot of things that are going to go into this to help support the way we design. But I'm not going to try to capture necessarily the design intent of the part more so than the design intent of how it's used in the assembly. So it's a little bit different approach than what we typically would do. So I'm going to demo modeling a tension spring for this demonstration. So when we think about a tension spring, there are many, many variations of tension springs, probably more than we know, right? And their applications are just as varied, right? We use tension springs in almost every mechanical device known to man, practically, right? So these springs are used all over the place. So we're going to model one based on the dimensions of the spring as well as the end conditions of the spring. So if we look at the different options for end conditions, there's quite a choice here to create. But we're going to make it simple for this demonstration, and we're going to create this long rounded end hook over center end configuration, and then these are going to be kind of the dimensions as a guideline for modeling this spring. But before we get into that, we need to know a little bit more about how the spring is going to be used in the assembly. So we'll go ahead and get into the live demonstration right now. So in my assembly, I have this simple assembly that we're going to use to demonstrate this capability. And we're going to create a spring that's going to mount from this location basically in one part of the assembly through this hole here. And it's also going to pass through the hole on this lever over here. So we're going to build the spring that's going to be used in this assembly. And it's going to be assembled twice. And if you think about this, if we assemble another one in this location, it's going to be a little bit longer, but we're not going to model more than just one spring. We're going to make it so the spring can accommodate both of these scenarios. Typically, we'll download a spring from McMaster Carr or wherever the manufacturer might provide a model, but typically that's going to be an imported model, right? So this cannot vary. It doesn't give us anything to vary. So rather than importing these types of models, I'd rather build them myself to match the specifications provided by the manufacturer, but I'm going to build it in a way that is static, like we're seeing here, but also give it the ability to expand in the assembly. So when we look at the assembly again, there's a lot of things that we have to consider. It's more than just the length of the spring between the holes, right? If we look at a cross section through these holes, what we want to do is we want to make the spring mount through this hole, but it also has to kind of touch these edges on the corners here, right? So that's how that spring hook would go through that hole. And then the same thing is true on the other side where we have this other hole. We've got to make sure that that spring kind of hits those corners as it passes through the hole. So not only do I have to model the spring, but I kind of have to model the holes in the spring. And this is where I say, well, I'm not really trying to model this so I can document it. I'm going to model it so it represents not just the static state of the spring, but also the installed or varied state of the spring, in which case I do have to capture this geometry in some way or these dimensions so that I can vary them in the assembly. So with that, we're going to go ahead and build a brand new spring. And I'll just create a brand new part here. And I'm going to give it the name that represents the model that I want to build here. So it's a tension spring with the type of hook and, kind of some numbers that represent the size. And I'm going to use my default template. So in my default template, I have, some datum planes, a coordinate system, and I have some parameters that are in this model, right? And these are my default start part. I'm going to add two parameters to start with that are going to help us with this spring model. And I'm going to add first the parameter for the wire diameter of this spring. And I'm going to make it be 0.0625, basically a 16th of an inch. I'm also going to create a parameter for the body diameter of the spring. And it's going to be a real number at 0.75. Right? So those are the two parameters that are going to help me drive the geometry, not necessarily the variability, but the geometry that I need for the spring, because I'm going to use these dimensions over and over again. The next thing I'm going to do is I'm going to create a sketch that represents the ends of the hook ends of the spring. Now, we're really going to create a sweep for this spring, and we want to create the trajectory for the sweep. So this sketch is going to represent kind of part of the trajectory for this spring, and then we're going to create another feature that's going to represent kind of the coils for the spring. So we've got basically about 4 features that we're going to create in this model to complete the model. It's not very complicated at all. One of the challenges that we're going to have is this area right here, and that's the transition, right? So that's a very challenging, set of geometry to create, because it can't be created as part of a helical sweep. And that's what a lot of people start out with when they think of a spring. Oh, it's going to be a helical sweep. We really can't create a helical sweep and capture that geometry. It's very challenging to do. So we're going to take a little bit different approach, and we're not going to use a helical sweep, but we are going to, of course, create that helix. So back to my model here. On the front sketching plane, or front datum plane, I'm just going to create a sketch that's going to represent part of this sweep trajectory. And this is just going to be the hook ends on this spring. I'm going to start out with a center line that represents, of course, the center of the spring. And that's a construction center line. I don't really need a datum center line here, but I do need a datum center line for mounting purposes, right? And that's going to give me the ability to assemble this spring through those holes that I showed you in the assembly. I'm also going to create a datum point at those same locations, which gives me, some geometry that I may use for assembly purposes. And I'm going to create a couple more points in a moment here, but those two help me kind of lay this out. I'm also going to make this be symmetric around my top datum plane. So we'll just give that symmetry there. And then I want the dimension between the holes, which is really kind of the length of the spring. Whoop, let me do that again. One more time. I got to click a little slower sometimes. And I'm going to say that that is going to be 7 for now. That's going to change later, but I'm just trying to put it in to context of how big this spring is going to be, which really we're modeling that 6-inch tension spring. Now what I'm going to do is I'm going to model the holes at each end. And I can't do this with solid geometry because it's not going to end up as part of my trajectory. But I do need to capture those dimensions. So to do that, I'm going to use construction geometry. And I'm going to create a rectangle at each location. And I'm going to let it snap to being symmetric here. And I don't really care too much about the size because that's going to be something that would vary in the context of the assembly, right? So I'm going to go ahead and just give it some basic dimensions for now. Whoops, again, I'm clicking too fast here. Sorry about that. That's going to be 1/8 of an inch for the thickness of the material. And then the diameter of the hole, I'm just going to make be 1/4 of an inch for now. So that represents my whole geometry for one end of the spring, and we're going to do the exact same thing at the other end. So I'll create some construction geometry, a rectangle, we'll let it snap, we'll give it that same dimension scheme, right? 0.125 here, and then another one here at 0.25. Now keep in mind, these will change when I assemble. I'm just giving this a dimension scheme so I have something to change. And I also have the geometry as construction geometry to help make the other geometry required for the hook ends. So the other geometry that is required is I need to know that spring is going to hit those two corners of that hole, right? So I'm going to give it an arc here that represents that. And I don't really care, again, the dimensions for the arc. I'm just going to go ahead and create that. And then I'll do the same thing on the other end here. We'll create another arc, center and ends. And again, I'm not too concerned with the dimensions for that because I'm going to have another piece of geometry that's going to represent that. Now I'm going to put a construction point at that location there, and I'll do another one at the other end here. Now that's actually going to represent the length of the spring. So we'll go ahead and give that a dimension for now. So I'm going to go ahead and say there from that point, and we'll zoom into the other point and we'll give it that dimension. And that again might change later. I'm just putting that in there for now. So I have that dimension scheme. Now what we're going to do is we're going to create another construction circle. And this is going to represent the wire diameter for this spring. So I'm going to create one here that goes to that point right there. And then I'll do another one at the other end. We'll do the same geometry, right? And again, we're going to represent that at this end. And I don't care about the size because we're going to change that later. Now, that does need to be equal. So I'm going to say this circle is equal to the other circle on the other end, right? I'm going to give it a diameter dimension. And then that dimension is going to equal my wire diameter. So we'll go ahead and write that relation here in the sketch. So I'm going to say that that relation, SD17, is equal to the wire underscore diameter. Okay, we'll check that relation, make sure Creo can do that, and then we'll say okay. So that diameter now goes to the size of the wire. So this is the layout geometry that I need to control the dimensions of the spring. Now I'm ready to create the spring hook geometry. So that's going to be solid geometry. So we'll uncheck the construction geometry. And then I'm going to create another center and ends arc. And I'm going to let it snap to the center of this arc right here. So we'll let it snap right there. And then we're also going to make it pass through that center of this, the wire, right? So we'll just let it snap there as well. And then I'm just going to throw that in there real quick. Now what I want is I'm going to say that the end of the arc is horizontal with its center. And then I'm going to give it a, whoops, I might have another constraint here that I got to add. But then I'm going to add this dimension that is the angle dimension for the arc. Whoops. Didn't click enough here. One more time. One click, two clicks, three clicks gives me the arc length. But that's a dimension that I can change to be an angle dimension, right? So we'll just toggle that to be, if I can get it here, toggle that to, sorry about this, I got so many things popping up here. That is going to be an angle dimension, and I want that to be 180. So I think I've got some constraints that are giving me a little bit of a problem here. And we're going to try and find those real quick. let me undo this. Why is that horizontal? We're going to just create a new arc here because I don't know where I got those constraints, but we'll try that one more time. We're going to go through here, boom, and I'm not going to go as far. There we go. Now we'll add that dimension. There. This is going to be horizontal. And then that dimension is going to be an angle dimension, so we'll toggle that. And I want that to be 195, right? So I get a little bit more of a hook. And then we're going to put a line here to there. And that represents one end of the hook, with the dimension being from the end to that location right there, that point. And that's going to be 0.875, right? So that represents one end of the hook. And then we'll do the same thing on the other end. Okay, so at this point, I got to change one dimension here, and that's going to be, this is a diameter dimension. And that's also going to be representative of the body diameter minus the wire diameter. So we're going to write another relation here that says that SD27 is equal to the body diameter minus the wire diameter. Okay, we'll check that again. Looks good. And then we'll say, okay. So that updated that geometry to look like that. I'm going to move these dimensions out a little bit just so we can see them a little bit better. We'll do something like that. And then there we have it. Now I've got to build the same geometry on the other side, and then we'll make some things equal here. I do want to add a reference dimension just because I like to know what that length is. We'll add that as a reference dimension. And then we'll go ahead and build this dimension on the other side, geometry, excuse me. So we're going to do that same arc, let it snap there. It's going to be something like this. We'll come around there. That's going to be horizontal. We're going to give this that angle dimension. Oops. Angle dimension, sorry about that. And that's the arc length, but we're just going to toggle that to be an angle, and then we'll give it that 195 value. And then we're going to make those dimensions be equal. So that dimension is equal to this dimension here. That way, if something changes, that does the same thing, right? And then we'll just drag that in, something like that. Then we'll create that line one more time. And then that line will be equal to this other line here. All right. So that way we've got the same geometry on both ends of this sketch. And whoops, we want to get rid of a dimension here. Sometimes if you just change a dimension to be a reference dimension, you get the results that you want. All right, so that's the layout. Now, I know that, and I'm just going to go ahead and delete that dimension for now, and I'm going to delete this dimension, because what I want is I'm going to go ahead and add the dimension between these 2 points, right? And that's going to be a reference dimension ultimately, just because I want to know what that is, right? So we're saying that's a reference dimension. I also am going to give another dimension from this point here to this point since I deleted it. We'll put that out there. Now that's the dimension that I want to be 6. So I'm going to go ahead and change that to 6 right now, because that's the dimension off of my chart. But for me to assemble this, I need the dimension between the holes. We'll put that there, okay? And then that 6-inch dimension will be the reference if we can get that to show up. It didn't show up in here, so we're just going to make that be the reference. That really should be the reference. So we'll change that right now. That's reference. And then this one we're going to toggle to be a real dimension. So that's the dimension between the holes. This is just for reference to demonstrate or illustrate the length of the spring. This is kind of the length of the body and a little bit more, and I'll explain that in a moment. The length of the body really should be 4 inches, but I added a 1/4 of an inch, and I'll explain why when we do the rest of the trajectory. But this is going to give me all the geometry that I need as the start of my sweep, but also give me the dimensions that I need to vary this when I assemble it. Okay, so now what I'll do is I'll complete that. And then I'm going to create, whoops, I need one more thing to add here. Sorry about that. I want to add some more points in here because I'm going to use these points for assembly purposes. I want to have everything that I need to possibly assemble this spring. So I'm going to give it those points. Okay, now what I'm going to do is I'm going to create a cylinder that I'm going to use to represent the body of this spring. And then that cylinder is going to give me something to create what's called a wrap feature. If you're not familiar with a wrap feature, but that allows me to take a sketch and wrap it around a surface. So what I'll do here is on my top datum plane, I'm going to create an extrude, and I'm going to reference that endpoint right there. So we're going to create a reference for that sketch geometry. And then we're going to create a circle. Okay. Now, because I'm referencing the geometry, I don't need any dimensions, but I am going to need a dimension later on in some relations that I create. So I'm going to just give this a reference dimension for its diameter. And then we're going to use that later. Now this is going to be a surface, so we'll toggle that to a surface. And my depth options are going to be basically to the reference at the end of each of those sketches, right? So if we take a look at that now, that represents kind of the body of the spring, and now we've got the hook ends of the spring. And so we just have to create the rest of the coil. Like I said, this is not going to be a helical sweep. This is going to be just a regular sweep, but to create the trajectory, we're going to use this feature called a wrap feature. All right. So this is a very unused feature. Unfortunately, if more people knew what it did and knew how to use it, they'd probably use it more. Right. But what I'm going to do is I'm going to create this wrap feature. I'm going to define my sketch for this wrap. I'm going to define a datum plane for that sketch, which is going to be parallel with right, and it's going to go through that vertice right there. So that becomes my sketching plane for this wrap. And then we're going to create the sketch. Now, I don't like the way this was set up, so we're going to go ahead and make the top face the top of the screen, and then we're good to go here. I'm going to reference the ends of this cylinder. So we'll reference that curve there and that curve there. And then we're going to create a construction coordinate system. Now, I'm going to put it right here, and I'm going to make the y-axis be vertical. this is required in a wrap feature. Like I said, we're going to create a sketch or a curve that's going to wrap around the cylinder. You have to think of a wrap feature like putting a bumper sticker on your car, where you kind of use your thumb to hold the corner down, and then you spread the bumper sticker. Well, this coordinate system represents your thumb in that, and then we're going to create the rest of the sticker here. Now I'm going to create a construction point that's kind of in line with this, and I'm going to create it out here, right? And then I'm going to give this dimension from the center line to that point. And we're going to use that in a relation in just a moment. Okay, and then what we're going to do is we're going to create the geometry that represents the rest of this coil. And we're going to include that little transition at each end. And that's why I made this a 1/4 of an inch longer, because we're going to need to consume that space. So I'm going to start by creating an arc. And we'll use the center and ends. That works for me. And I'm going to create an arc here, just like that. And I don't care the dimensions yet. And I'm going to create another one down here, center and ends. And then we'll create a line between them. And then we'll make them be tangent. One there and one there. Now what we'll do is we're going to make those arcs be equal. One there and there. And then I'm going to add a relation for this, and I'm going to make it be twice the diameter of the wire. And our wire is a 1/16 of an inch. So if we make it twice the diameter, it's going to be an 1/8 of an inch. And we're going to have that at each end of the spring. So that represents the 1/4 of an inch that I made this body longer. Okay, so let's write that relation right now. Tools, relations. We're going to say SD3 is equal to wire diameter times 2. And we'll verify that. Looks good. And we're going to say OK. Now what we're going to do is we're going to make this dimension equal the length of the coil around the cylinder. And I just know from taking some measurements before that I've got to wrap this wire around the cylinder 64.5 times, right? So to do that, we're going to go ahead to Tools and Relations. And we're going to say that SD2. And I need to make sure I can get my other dimension here. So I'm going to get that extrude right there. See if I can't grab that dimension. Yeah, I need to just write that relation in just a second here. We're going to say that I need to know in that extrude what that dimension is. It's SD or D15, I should say. So that's what I'm going to use in my relation. So we'll edit that. We're going to edit the sketch. And we're going to write the relation that says SD2 is equal to the diameter, D15, times pi, which represents the circumference. And I said we were going to go around by 64.5 times. We'll check that. Looks good. We'll say OK. And then that just puts that line way the heck out here. But that's going to wrap around that cylinder now 64.5 times. So we'll say OK here. And we'll say OK. So that's the wrap feature. As you can see, let me hide this extrude. That represents that coil. And since I'm starting out on one side of the cylinder, and I have to end on the other side of the cylinder, that's where I get that 64.5. I need to go 1/2 of another rotation there. So now I'm going to use those curves for my trajectory. So we'll say sweep. I'm going to use that curve first. I'm going to hold my shift key down. I'm going to select that curve and that curve. Now all I got to do is sketch the diameter of the wire. So we'll just put in a circle here. And I don't care how big it's going to be because I'm going to drive that with a relation. So we'll go to Tools and Relations. And we're just going to say SD3 is equal to the wire underscore diameter. And then we're going to say OK. And then that represents my sweep. Okay? Pretty straightforward. And again, that's how we get that transition right in there, is by creating that wrap feature, we can actually make that transition. Now, I visit customers all over the country, all over the world for that matter, and I've seen so many times where users will try to create a spring like this, and they do it with a helical sweep, and then they just cannot model this. So what they'll do is they'll end up with just a sharp corner in here, but then that doesn't lend itself to a true representation of the spring. All right. So with that, I'm going to save this model. First, I'm going to save my layers. We're going to hide this stuff we don't need to see. We're going to go in here and save my layers so that those stay off. We'll just say save the status, and then we will save this part. Make sure I'm going in my working directory. Boom. Let's regenerate it just for fun, and then we'll save it. Okay. Now, let's go ahead and put that in this assembly. All right. So what we're going to do here is we need to know some axes, and I think we may not need some planes, but we'll turn those on anyway. And then I'm going to assemble that spring. So this is the one I just created. And to assemble it, we're going to assemble the geometry from the axes that we created in here. So we do need to unhide that sketch for now. So we'll show that so we can get to that geometry. And I'm going to say that I want that axis to be assembled with this axis here. And that's going to be a coincident. Okay. Now we're going to assemble a new constraint. And this one is going to be the axes on the other end, if we can get to it here. See if I can't find it. We may just rotate that out so we can get to it. There it is. And I'm going to take that axis and put it in that hole. Now that's going to be oriented by its nature, right? We don't have the length yet for this. We're going to do that in a moment. But that's how that gets assembled there. And then we're going to add one more, and I'm going to use the datum points that we created in the sketch. And we're going to just put that 1 point right there and make it coincident with that surface. Okay? And then that's fully assembled. We can see that, but it certainly doesn't represent, how we want it to be assembled. So we're going to fix that in a moment. But let's take a look at this cross section here, just so we can see how that spring is assembled here, right? So it's not really where we want it to be, but that's why we added that construction geometry to the sketch of those hook ends so that we can capture that. So to do that now, we're going to make those dimensions be variable. So for that, we're going to take that spring and we're going to use this flexible component and we're going to make it be flexible. And we're going to use dimensions for its flexibility. But let's talk about this first. We have dimensions by default that we can make flexible, but other things can vary in the context of an assembly. We could vary features. There may be some features that you suppress or resume. You may change your geometric tolerances if you like to. I don't know why they would change in the assembly, but they could, right? Even your material could be something different in the assembly, but again, I don't know why that would change. Even your surface finishes. I don't know why those would change, but they could. But parameters are certainly something that we can change as well. But we're really going to change dimensions, and we're going to use the dimensions from this sketch, and we're going to get the width of the hole, the diameter of the hole on this end. We're going to get the width and diameter on this end, and we're going to get the length of the spring, and then we're going to say okay. So those can all now be varied in the context of the assembly. So the first thing I'm going to vary is the length of the spring. And to do that, I'm going to take a measurement between the axes here. So we'll say by distance is my option to vary this. And I'm just going to measure from one axis to the other. If I can get to it here. There it is right there. So hold on a second here. By distance, let me do that again. By distance, we want to say from one center line, and we'll go to the other center line. Make sure I'm getting the right one here. There we go. So that distance is 6.83 and some change. So that's fine. It's it is what it is, right? But then we're going to say, well, what about that hole right there? We're going to say that is going to be by a distance, and we're going to measure the outside of that surface to the outside that surface, and that is 1/2 of an inch. We're okay there. We'll do the next one is the diameter, and we're just going to measure the diameter of that hole. We'll go to the other end and do the same thing. We're going to say that dimension is by distance, and we're going to say from one side to the other. And we're also going to change the diameter by the diameter of the hole. So with all of those variables now designated, and we regenerate the spring, it fits through that hole. Okay. Now that's what's important, is that the way that spring fits in there, it hits those two corners. It's the same shape on the other end. However, the two corners that it hits are further apart. All right. So, and you can also see the spring is a little bit expanded here because that was the distance between the holes. We'll go ahead and get out of the cross section. And that's how that spring works. Now, what happens is if this lever angle were to change, then what happens to the spring? Well, because we assembled it correctly, if I do take that and I change its angle, let's just go 15 degrees here, right? And we'll regenerate the assembly. The spring is going to expand accordingly because that's the way we assembled it. Okay. If I change the thickness for that component, let's say I want to make that extrude instead of being 1/8 of an inch thick, right? Let's make that be 1/4 of an inch thick, right? Of course, that changes the geometry in this hole. So we're going to go ahead and regenerate that. That gets thicker, but as you can see, our spring is still assembled correctly. Okay, so these are things that when we create these types of components, not only do we have to consider how it's modeled in a static state, but we also have to incorporate into that model all the things that could be variable in the assembly. This is, a model that has 5 variable dimensions to assemble it. Most models might just have 1, but in this case, pretty complicated to model this and capture that geometry. But once you see it's done, it's not that bad. All right, so let's go ahead and assemble the other spring. I'm going to undo this, and we'll just put the other spring in place. So we'll assemble another one, and we're going to assemble this the same exact way, where we've got one axis to the axes in the hole. Those are going to be coincident. We're going to add another constraint. We're going to put the other axes, that one, through this hole here, right? And, oops, did I get that right? No, we want those to be coincident. And no, actually, those need to be oriented. Sorry about that. Oriented. Come on, Sean. And then we're going to add one more constraint, and we're going to use that datum point on the side there. So when I created that sketch, I gave myself a couple of datum points in here because I don't necessarily know how this spring might be assembled from one to the next. So I've got a couple points in here that I can use to assemble that. All right, so that is in place there. Now we just need to make it be variable. So we'll go ahead and say flexible component, make flexible. Again, we're going to use the dimensions from that sketch. We'll go ahead and load all those dimensions in to the buffer. And we want the one more right here. We're going to say OK, and then we're just going to set their values. So the first one is by distance. 1, 2. The next one is by diameter of the hole. Okay, there. The next one is by distance at the other end. One surface to the other. And then the diameter of the hole. And then the length is going to be distance again. And we're going to use that center line to that center line. A little bit longer on this one. Same spring, assembled in two different positions in the assembly, and that's what we get. Okay, so I'm happy to answer questions at this point.
Yeah, let's see. We do have one question from Garrett. Let's see what he says. What would be the cons of using the flexible modeling method for a rivet purchase versus deformed state model?
So it'd be very difficult to take this imported part and give it anything flexibility, because there's no way to expand the coils in here. Sure, I could probably make these distances change. I could, certainly do that, but the coils of the spring I'd have a really hard time doing. So flexible modeling might work in some situations, but in this case, it wouldn't give me any benefit. I hope that answers your question.
Great. There's no other questions yet, and Garrett gave a thumbs up there, so looks like he did. Yeah, we'll just take a few more minutes pause here. If there are any more questions, yeah, feel free to submit them. We'll take them as they come in. And if there are no questions, we'll go ahead, we can give you guys back some of your day. We'll give it a few minutes here.
Okay. Well, while we're waiting, I'll show a few more examples of a flexible component. Now, somebody had just asked about using the flexible modeling environment to do that. So, how would I do that? If I have a battery clip that's imported, here's some geometry that got imported, and I want to be able to put a battery in this clip in the assembly, and so that's going to be represented by that diameter. However, I don't have that geometry or that dimension. So what I'm going to do is I'm going to give it some flexibility in the context here that I can use in the assembly. So what I'll do here is I'm going to go to flexible modeling. And the first thing I'm going to do is I'm going to say that that surface there is the mirror image of that surface. And then we'll let Creo figure out what's the mirror geometry. And then what we're going to do is, working in the front, we're going to take whoops, make sure I'm using my correct selection tool here. We're going to take all this geometry here, and not all of that. We want just that much, and we're going to move it. And we're going to move it by a motion reference using this line right there. And then we're going to rotate that over. I'm going to give it a dimension of 0, because that's what I want. I just want the dimension. And then I'm also going to make it be propagate to the symmetry on that one. And then we're going to say OK. So what that gives me now is a dimension in the assembly that I can modify. So if I take that and say, well, it's not 0, it might be 5 degrees that's going to expand it, or it might be -5 degrees, that's going to expand it. There we go. So we have that ability now to vary this thing in the context of the assembly. So this is an example where I would use the flexible modeling environment because I can get away with it. But that spring, there's nothing I can do with that. But now I just leave that at 0. And then when I assemble it, I can basically measure the diameter of the battery. Another example would be if I look at this hose clamp, and we're going to do this. And I'm going to put a hose clamp in 2 locations here. I'm going to use the same clamp, right? So we'll assemble this clamp that I created. And I'm going to assemble it, this one by coordinate system. So there's one, I think it's that one too. I like that, it's fully constrained. And then we'll assemble another one by the coordinate system here to that coordinate system. Same exact part, right? But if I want to make them variable, I'm going to set that here, make flexible. This one is going to be a dimension. That's going to be based by the diameter of that hose. Boom. That's how that fits in there. We'll do the same thing for the other one. It's going to be the dimension for the diameter. We're going to measure that by the diameter of that hose. So here again, we have the same exact part assembled in 2 different locations, 2 different variations. And I could do this over and over again with no need for a family table or no need to create additional parts. It's all the same part, right? Now this one's a little bit trickier, this part, if we take a look at that. This is a multi-body part for one, right? So we've got 3 bodies. We've got the case, the screw, and the actual strap itself. And this is using some, it's not a complicated model. It's just the thought process that goes into making this, it makes it a little more complicated. Really what's driving this model when I change this diameter, right? If I say, well, I want to make that be 1, look what happens. That strap actually keeps extending. So how that works in this case is that uses what's called a perimeter dimension in the context of the sketch. And it also uses a wrap, not a wrap feature, a spinal bend feature. So a spinal bend lets me take a solid and bend it about a curve. Of course, it wants to do the whole solid, which is why this part is best modeled as a multi-body part, because now I can just bend one of the 3 pieces, which in this case would be the strap. So really what makes this one work is if we look at this sketch right here. And basically what I have is a representation of how that strap wraps around. In the sketch, we're allowed to use what's called a perimeter dimension. We only get 1 of them, but I only need 1 in this case. And I take the measurement of all of those curves and I give that perimeter dimension. But a perimeter dimension needs some variability. And so I use that arc length dimension that you saw me create earlier as my variable. So the length of this curve will always be 6 inches. But if the diameter changes, that causes that variable length to change, and that strap just keeps coming out further and further, right? So a very simple idea, but to execute it a little bit challenging because we have distances between the geometry that we need to maintain and things like that, so the feature doesn't fail. But this model, I mean, I've regenerated this model, and it's hard to make it fail. But little creative techniques here to make that work. Okay, so again, well, we've got a few more minutes for questions.
Yeah, we do have some more questions have come in. Let's see. I got one from Dustin. When you were assembling the spring, you were adding the flexibility each time it was added. Can
Yes.
we add the flexible features to the spring and store it it that way so every time we assemble it, it will have the option to use the flexibility?
Yes, absolutely. Now, I don't personally like to do that for my models, but yes, you absolutely can do that. So in the part, what we'll do is go to File, Prepare, Model Properties. And then down below here under Tools, you see Flexible. So I can actually give it those dimensions for flexibility, right? So I'm going to say, well, I want to get dimensions off of that sketch. I want that dimension, that dimension, that dimension, that one, and that one, right? So it doesn't ask me how I want to measure them here. It just says those are going to be the variable dimensions when I assemble it. Okay. Now, watch what happens though. And this is why I don't necessarily like to do that because when I assemble that spring now, whoops, working directory, where's that spring? It wants to ask me, do I want to use those flexibilities? Well, the problem with this is if I say yes, it wants to bring that spring in and it wants me to measure before I assemble it. Well, I don't know how to measure it because I don't know which end is which, right? So that's what it's at. So I gotta define the variability now before I assemble it. And that's a little bit harder in the case of this spring. So case by case, I'll leave it up to you to decide whether or not you want to create that flexibility in the part itself or just wait till you get to the assembly. Okay, I hope that answers your question.
All right, we got another one from Shane. He says, does the diameter of the body of the spring reduce when expanded?
Well, I could do that, and that should be some advanced math. Is it worth it? I don't know if it's worth it, but yeah, I could do that. And I understand what you're saying. As you stretch that spring out, the wire length doesn't change, so the diameter has to change to accommodate. So yeah, I could do it, and I've thought many times about doing that, but I think that just gives another level of complexity. Now, the thing is how far am I going to ever stretch that spring, right? And that's what you have to consider. If I go this far with it, I'm probably not adding too much to the wire length. We could probably measure if we wanted to, but I'm not making it be that much longer. If I were to make that spring stretch, it's probably the wrong size spring, right? So I probably have to go up to the next size spring. But to answer your question, yes, I could add that variability if I wanted to.
All right,
I
we got
just
another. Oh, go
go
ahead.
ahead.
Sorry, Shane.
No, I just go ahead. I'm
All
ready.
right. Yeah, so we got another a question from Gordon. What concerns about the performance of a large assembly should we be aware of for flexible components? If we model a rivet and make thousands of them flexible, what happens?
Well, that is going to cause some assembly performance issues, right? Because it does have to regenerate each one of those versions. Now, if you do it 1,000 times and they have 1,000 different versions, then you might want to take a different approach. But you could also use a simplified representation to omit those kinds of things during regeneration, because you really, do I need to regenerate those every time? Probably not, right? So I would certainly, I could do that, but I would create a simplified representation to exclude those things so they don't regenerate every time.
All right, we got one more question from Wayne. This is our last question. Show how to make part flexible before assembling.
I did that, right? That was in the part itself. Whoops. We'll do, where's that right there? So what I did was I went to File, Prepare, Model Properties, and then here you can define the flexibility, which is what I did. What's going to change, right? But again, what happens with that is then I have to, before I assemble it, it's going to want me to define what those values are, and I may not know what they are until I assemble it. So this is the reason I don't necessarily like to do it for a part like this. Now, for that hose clamp you know, it's only one dimension and I know it's going to be a diameter, I could do that and that wouldn't bother me. But for this one, little bit more challenging.
All right, well, that's all of our questions, and that brings us right to the end, right on time. So, again, thank you everybody for attending. And Sean, thank you once again for an amazing presentation. Once again, if you guys have registered or you were here, you'll be sent a copy of this recording automatically. And you can also find it on our YouTube channel at TriStar PLM or on our website at www.tristar.com. So thanks again, everybody, and we hope you have a great rest of your week. Bye.
Thank you, everybody.